So welcome to this short tutorial on how to use the Huygens Remote Manager at the CIF platform. So just as a prerequisite, in order to work correctly with this software, you will want to use Google Chrome as a web browser to avoid problems further down the line where you might not see your files, for instance, and errors like that. So make sure you are using Google Chrome first. Then to go to this portal, you need to go to this web address, which is written here, or you can find the link directly on the CIF website, and if you look for the Deconvolution service. Then to log in here, you will need to be a registered CIF user to have a UNIL account that is member of the CIF group. And for the demonstration purpose, I will use here a service account like this. And then press login to enter and see the home page. Here we go. So this is the main interface of the Huygens Remote Manager once you are logged in. And you will see several sections here. The first one obviously is to launch the jobs, which are the deconvolution jobs. Raw images will allow you to upload the images that you have acquired with the microscopes, so images in the native format. Results will display all the images that have been already processed. Queue status will allow you to check the current queue, so that includes all the jobs, not only your jobs, but the jobs from other users as well. And so you will be able to see where your current tasks are in the queue position. And finally, if you're interested in, you can see some statistics on what you have done using this software. Okay, now let's upload some images. So we click here on raw images, and to upload some images, we can click here on the blue arrow, and we get this dialog where we can drop files directly here, or just click on select files and open up file selector. Here I will just use some images I've made with the Nikon spinning disk used in white film mode. So this is almost 3 GB stack, multiple channels, and let's just drag and drop it here. And at this point here, you can see that there is a small pen tool that allows you to rename the file directly from the upload dialog. So just a small warning: if your file name contains a dot besides the extension itself, you will get into trouble. So make sure the file name doesn't contain any dots. So I will just convert this, for instance, and also getting rid of the spaces is always a good idea. So let's just call this Whitefield stack, for instance. Press enter and then upload. So you can watch the progress of the upload here, and provided you are on a good connection, you can actually upload a lot of files pretty fast. And since you are on the topic of uploading files, there is a policy currently on the server to avoid saturation, and we automatically remove files older than 15 days. So make sure that once you have uploaded your files, process them, and got back your results, you would store everything safely elsewhere than on this server. So here we go. We can see whitefieldstack.nd2 because it's a Nikon file. And if I click on it, I see this this icon that allows me to generate a preview. So let's do this. Sometimes it fails, but here in this case it worked. So this is the preview of the stack, and you can see here some information about the stack itself. So the definition of the image, the number of slices, the number of channels, and the actual size of the whole dataset with a small scale here. So this is a maximum intensity projection from the top and here from the side. So now we can go back to the home page to start the job. Okay, so let's go back to the home page. And now let's start the deconvolution job itself. So we can go here on launch jobs. And first of all, here we have to select the file extension. So this acts like a filter. If you have many files on the server, it will help you to restrain a bit the list of files. So in my case, I want to look for Nikon ND2 files here. And here it is. This is the Whitefield stack as I've uploaded it with the preview, and then I can add it to my list of selected images like this. So if you have multiple files acquired in the exact same conditions, so same size, same number of channels, same exposure time, if it's a camera, and so on, then you can add them to this list, and they will be processed as individual jobs. But you have to make sure that every parameter is the same, because later on we will have to specify how these images were acquired, and we can specify this only once. So obviously, if you have different data sets, this will not work. So now we can proceed to the next step here by clicking on this green arrow. Okay, now on this page we have to select or create what is called an image template. So this is a set of parameters that describes how the images were acquired. So the easiest way for you to work is to actually build it from the image. So provided you have a file with metadata inside, and this is always almost the time with files coming from well-known brands like Zeiss, Nikon, Leica, you will get all this data read directly by the software. And to do this, you click here on From Image, because I want to generate a template from the image itself. I have to select the image here and press OK. And now I should see here some parameters and verify them. And sometimes it gets them right, and sometimes it's not the case. So here, for instance, this is a triple channel image. I have opened it here in the Nikon viewer, so you can see it here. This is the original dataset, so it's a stack with 3 different channels. And if I want to get the information I need, I can go here to Image Properties, and you will see something similar on each of the viewers from any microscope brand. They deliver a free software to view the images, and you will probably have at some point a menu or something to display those information. And here, so you can see in the detailed view that the image was acquired with 60x objective or an immersion objective, and we had 3 channels, so DAPI, GFP, Sci3 here. Acquisition details will get you even more information about what has been acquired and how. So this is what I wanted to have. So now let's go back to the Huygens Remote Manager. So we actually have 3 channels here. We will use a theoretical PSF, so I will not go into the details here because this is besides the point of this tutorial. But just know that measured PSFs can be used if they are produced by the Huygens suite that is installed currently at Dorini. So that's why most of the time we will use theoretical PSFs. Now, this image is a white field type image. The NA is correct because it's the 60 times objective. Here, the software has correctly read the emission parameter, but not the excitation. So again, we can look here if the information is actually stored. So 388. And we can fill this by ourselves. So see, this should be 488, and this is 555 nanometer. Then the objective type is oil, so this is correct. The sample medium, we can leave this as well. And let's go to the next page here, which is where we have to specify the voxel size. So this is the calibration of the image. So this, you can, I think most of the time you can be confident that this is well read by the system. If it's not the case, and you have trouble finding the right values here, you can always contact me or someone in the staff and help you with this, because this is something that is not always correctly displayed in the files. And then press OK. And now we have a new image template, which is called based on the name of the file here. And if this is not something you want to keep it as is, you can actually rename it by using a small trick, because there is no rename tool here. The small trick is to duplicate here this template, and then you can give it a more meaningful name. So my image template, for instance, let's create this, and then you can get rid of the old copy like this. And then we can proceed to the next step, which is to select or create a deconvolution template like this. Okay, so deconvolution template or restoration template actually. So this is a bit more, much more simple, because the way to go is actually to select here one of those presets here and adapt them to your needs. So let's try to use precise here. And we can now edit this preset here. And the only thing we need to update here is the signal to noise ratio. So to do this, we will estimate the signal to noise ratio from the image. So click here, select our stack here, and click on this small calculator icon. And now the program will give us an estimation of the noise levels by building different simulations, and it's up to us to decide if those signal to noise ratios are correct or not. So here it takes quite a bit of time, I think, because the data set is quite large. Hopefully it's not stuck. Okay. Here we go. So, how to read this? You get here the original image. So this is just a cropped area of the original image. And here you can see some simulation of different signal-to-noise ratio levels here. And it will suggest you some values here. Actually, the problem here is that those signal-to-noise ratio values cannot go higher than 100 here. So make sure if it's above 100 to specify 100. So if I check them here, there should be correct here. If you compare the original, for instance, here to this, the original is definitely better than what we see here. But 143 is maybe too high anyway. So if you accept here the suggested values by just clicking here, you will probably get into an error by telling you that the values are too high. Here it has just copied everything, but if I want to save here the template, it will complain. SNR, the value must be inferior to 100. So let's put this back to 100 like this, and it should be fine. Press OK. And then we can proceed to the last step, which is to create the job itself. So for this last step, we can review all the parameters here that we have selected using our templates. And here we don't have any analysis license, so we don't have anything to check. The only thing you have to do to make sure it's correctly selected is the output file format here. So by default it says ICS, but the most common file format you might encounter actually is OME, which is compatible with any kind of imaging processing package. So let's select OME TIFF. It says OME XML, but it's a TIFF file, and press OK. And when you do this, your job will start and will be added to the queue. So here we can see that we have one job in the queue here. So let's have a look. And this is how it looks like. It's green when the item in the queue is started here. And once it's processed, this will disappear. And you will get an email notification with a link to the results. So in the case of multiple users using the system at the same time, the queue will try to prioritize having multiple users getting results, not having the first user having all his files processed first, and then you will get to the next slot. Because this way there's less waiting time for everyone. So this is not a first in, first served system. So since this will take a while, let's just wait a bit, and then we will be able to review the results. Okay, so we can see that our queue is empty now because there is no jobs left in the queue. And if we want to look at the results, we can click here in the results folder and we can select our file here. And we see a thumbnail here of the resulting deconvolved image. If you click on it, you will see a comparison between the original dataset and the restored dataset. So in this case, the improvement is quite impressive because the original dataset is a white filled image stack. If you have used a confocal stack, the improvement would be a bit less impressive, but you would still get some a bit better contrast, more resolution in the Z direction, and other additional gains. So you can review the parameters here, and if you look at this page, you will see all the parameters you have used, and here you can ignore this message. This means just that we have selected white fill, but the file was detected as a spinning disk dataset. That's because we have used actually a spinning disk microscope, but in the white fill mode. Here there is a log, and you can see all the steps that were taken during the deconvolution. And for instance, if you browse down here, you can see that each channel took approximately 1 minute to process. So it's, I think it's quite nice considering the overall size of the dataset. SFP shows you 3D representation, like a projection you can get from software packages like Imaris. Slicer, in this case, doesn't work, but it will give you slice-by-slice view of the dataset. You can view this also by clicking here on Stack Movie and download a small movie here. And if you open it, it will show you the same view here, but as a video file. So you can get here a small preview of the deconvolved dataset. So if you're satisfied with the results, you can pack and download everything by clicking here on the green arrow. And if you are just interested in the file itself, in the result itself, you can go back here, select the file, and download the results. Here, confirm, and you download. Okay, so thank you for following this tutorial, and if you have any questions, feel free to contact me at yannick.kremp.unil.ch. Bye-bye.